I heard a paleontologist say recently that ancient fish are, the ultimate evolutionary success story, that they hold the keys to pretty much everything that came after.
That's a fantastic way to put it.
And it feels like the perfect setup for our deep dive today. We're looking at some brand new 2025 research that's showing just how much we're still rewriting that story.
It's really incredible to see. I mean, you look at these ancient groups like the pycnodontiforms. These were an extinct line of ray fin fish that were just, well, they were the kings of the tropical seas for millions of years.
The hard-shelled prey eaters, right?
Exactly. From the late Triassic all the way to the Eocene. And now, thanks to a new find in Lebanon, we're meeting a brand new member of that club.
Okay, tell me about it. This is Calpagnatus picteti from the late Cretaceous.
That's the one. And it's a very striking animal. Imagine a fish shaped almost like an upright dinner plate, very deep-bodied. And its skull has these really unique features, like a sort of brush-like process on one of the bones, which helps place it right at the root of the main Pycnodontinae family tree. It shows just how fast these durophagus or hard-shell crushing specialists were diversifying.
Okay, so let's pivot from these marine specialists to a huge mystery on land, the origin of otophysians.
Ah, yes, the big one.
I mean, this is catfish, carp, tetras, two-thirds of all freshwater fish today, and the textbooks always assume they started in Pangean rivers.
That assumption has just been completely overturned. And it's all thanks to a fossil that's barely bigger than your thumbnail.
You're talking about Acronychthys mackinoi.
Acronychthys, a tiny, maybe 2-inch-long fish from 67-million-year-old river deposits up in Alberta, Canada.
So a tiny fossil rewriting a massive global chapter.
Yeah.
How did they even see the details they needed in something so small? Is it just about new tech?
It's absolutely the technology. They used high-resolution X-ray micro-CT scanning. It's basically a non-destructive virtual dissection. And they focused in on the microscopic bones of its Weberian apparatus. That's this amazing little chain of bones that connects the swim bladder to the inner ear.
Giving it super sensitive hearing.
Fantastic hearing, right. And analyzing that structure. Well, it pointed to a completely surprising marine origin for the whole group.
A marine origin, so not freshwater at all to begin with.
Not to begin with, no. It pushes their origins way back to the late Jurassic, maybe 154 million years ago. And it shows there wasn't just one move from salt to freshwater. There were at least 2 separate moves.
Wow. And the hearing was already good.
Incredibly good. They modeled its sensitivity and found it was already comparable to modern relatives like a zebrafish.
That kind of deep analysis.
Yeah.
Using complex simulations to connect microscopic bones to this huge evolutionary story. It actually reminds me of our sponsor, Embersilk. If you need help with AI training, automation, software development, or even just figuring out where AI agents could make the biggest impact for your business, you should check them out. They help you connect the dots in your data, kind of like how paleontologists are connecting the dots in these ancient fossils. Just visit embersilk.com. So speaking of connecting the dots, sometimes these new tools show us that a dot we thought we had in one place was actually completely wrong.
Right. A case of mistaken identity.
Let's talk about Sorbinicar axphoricea. This little teleost from Italy.
Yeah, this one was originally classified as an autophysine, but a re-examination showed it didn't have the key parts, like that Weberian apparatus we were just talking about.
So what is it?
Well, right now, it's Teleostae inserte sudis, which is a fancy way of saying we're not quite sure where it fits in the family tree just yet.
But its body tells a really clear story about how it lived, doesn't it?
Oh, absolutely. I mean, it looked almost like a little bulldozer. It had this massive head, a wide body, enlarged ribs, and a mouth that opened upwards.
A benthic ecology, right. A ground fish.
Exactly. It was living on the seafloor, probably using this ambush suction protrusion strategy to just vacuum up little animals.
So it's like a prototype bottom feeder. It was trying out this whole ground-dwelling strategy millions of years before it became a popular evolutionary move.
That's the perfect way to see it. It's this unexpected case of an extinct lineage pioneering that benthic niche long before the big modern families of bottom-dwelling fish really took over. It's a snapshot of an early experiment.
What's so inspiring about all this is seeing these ancient experiments, whether it's perfecting hearing or trying out a whole new habitat, that laid the groundwork for all the diversity we see today.
The story of life is so far from complete, and it feels like every tiny fossil we scan promises a whole new chapter.
And as the tech gets better, we're just going to learn more and more. It's fantastic. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.